This video will review exponent rules. So the first rule we're going to look at is called the product rule, also known as multiplying with exponents. Now when you have a multiplication problem, we are going to look to make sure that we have the same base. Notice our first example has an x for each base. So the product rule says that we are going to add the exponents on the like base. So notice our base is still x, and then what happens is we've added the exponent a with the exponent b. Now if you have a coefficient in front of your variable, you are still going to multiply the coefficients together. So in this example, m and n are acting as the coefficients. We're going to multiply the m times the n, and then because we have a base of x, notice what's happening with our exponent, the a and the b, we're going to add a plus b. Now let's see if we can put these ideas together for an example problem. So number one says 3x to the third, and then that little dot means multiplied by 2x to the second. So notice the coefficient 3 and 2 is going to be multiplied together. So I'm going to start with 3 times 2 for 6. Now I do have the base of x, so I am going to use x as my base, but I'm going to add those exponents. So I'm going to add the 2 and the 3 together. And 3 plus 2 will give me an exponent of 5. So the base will stay as an x, and my exponent will be a 5. Now we've got one more example. Example 2 is also a multiply problem, but notice instead of the dot between our two terms, they're using parentheses. Now that still means multiply. So let's zoom in here and take a look. Notice we have our coefficients, the 2 and the 3, so I'm going to multiply 2 times 3 for 6 in the beginning. Now here I have an a to the 5th, and I'm going to multiply with a to the 3rd. So only the like bases. I'm not looking at the b, just looking at the a. I'm going to add 5 plus 3. So we're going to have a to the 8th. Finally, we'll shift our attention to the b. So we have b to the 3rd, and we're going to multiply that by b to the 4th. So my base will stay b, and then remember you're going to add the exponents. We're going to add 3 plus 4 for b to the 7th. So we have one for you to try. If you're feeling confident and want to pause the video and try this last example here, I encourage you to go ahead and do so now. All right, check it out. How'd you do? I came up with 8x to the 7th, y to the 5th. If you got that, nice job. You are ready to move on to our second and final rule for the day. We're going to talk about the power of a power. Now the power of a power rule says when you have a base with an exponent, and that is being raised to another exponent. So you have one power in green and one power in yellow. We are going to multiply the exponents. That's our power of a power rule. So notice they kept their base as the x, and they are going to multiply the first power, which is a, with the second power, which is b. So let's take a look at an example. In our first example, the x is our base. So we're going to start our answer with the base of x. And notice we have our first power is a 3, and we have a second power, which is a 2. So we are going to multiply on our exponents 3 times 2. So for the final answer, we're going to have a base of x, but the power will be 6. So x to the 6th. And this rule can be applied with multiple exponents or multiple powers. So if you look at example 2, notice we have a base of y. So in our answer, we'll use y for the base, but look at the different exponents. We have our first exponent is a 4, our second exponent is a 5, and then we have a third exponent, which is a 3. So what that means is I'm going to multiply the 4 times the 5 times 3 for my final answer. So we're still going to have a base of y, and the power on our y is going to be 60. So y to the 60th power. Now this power rule can be expanded to different variables inside your parentheses, even a coefficient. So the expanded power rule says you are going to distribute your exponent. So notice the c, the power of c, is being distributed to the first part, the m. It's being distributed to the second part, that's our base x with a power of a. And it's going to be distributed to our base y with a power of b. So notice the coefficient of m in our answer has that power of c. And then if we move along, the x, which started with a power of a, notice its power is now a times c. Because that was our power of a power rule, we will multiply our exponents. And last but not least, we had our base of y with the power of b, and then notice when we distribute the power of c, your exponent will be the b times c. So to recap, the power of c is in each part because we're distributing. And that rule can apply to fractions as well. Notice on the right-hand side, the power of c got distributed to the top portion of the fraction, and it got distributed to the bottom portion of the fraction. So let's take a look at our example. It looks like we have 4, a to the 4th, b to the 6th, and that's being raised to the 3rd power. So let's distribute that power, and we're going to start with the coefficient of 4. And I'm going to have 4 raised to the 3rd power. Then we move on to a to the 4th, and we're going to raise that to the 3rd power. So using my power to a power rule, I'm going to use the base of a, but I am going to multiply 4 times 3. And finally, I have b to the 6th, but we're going to raise that to the 3rd power, so that's going to be a base of b, but we're going to multiply the 6 times 3. So my final answer, I'm going to write out 4 to the 3rd as 64, and I'm going to write out my a by multiplying 4 times 3, so a to the 12th power. And same thing with my b, I'm going to actually multiply the 6 times 3, so we're going to say b to the 18th power. Now the final example, we have a fraction all being raised to the 3rd power, so what I want to do is distribute that exponent of 3. Now I've got my coefficient of 2, and we're going to make sure that we raise that to the 3rd power. And I'm going to go ahead and take the next piece, that's the x to the 3rd, and we're going to raise that to the 3rd power. So what does that look like? We need to multiply our exponents 3 times 3. And the final piece here, this is my denominator, right? So we'll draw that fraction bar. It looks like we have y to the 4th on the bottom. And if I'm going to raise that to the 3rd power, we are going to multiply the exponents 4 times 3. So our final answer, get that fraction bar going, 2 to the third, that's like 2 times 2 times 2. That's going to give us an 8. And then for my x, remember we're multiplying 3 times 3, so the power on that will be 9. So we got 8x to the 9th on top. For the bottom, we said we're going to multiply 4 times 3, so it's y to the 12th power. Final answer. Woo! Now here's where I want you to pause the video. I want you to try this very last example. Let's see how your understanding of the power to a power rule is. Now for that last one, I came up with an answer of 16, x to the 24th, y to the 12th. And that right there is your power of a power rule. Awesome job, guys. Thanks for watching.